Good morning, Mohit, Sethi. I'm Chetan Anand.
Hi, good morning.
DIT.
Good morning. I am trying to share my slides and start the presentation. Sorry about being late by a couple of minutes.
Sir, we are yet to start the program. We are waiting for you.
Yeah.
And we'll have an introduction of the speaker, and later on you can take it over.
Okay.
Good morning, participants. Welcome to the Day 3, Session 1. Hopefully, you had a profitable session in the previous day, which happened to be hands-on sessions. And the speakers of the yesterday session have shared their mail IDs in asking for the queries, if any. You can directly be in touch with them in getting things being clarified with. For today, we are happy to have Mr. Mohit Sethi, Senior Researcher at Ericsson, Research Fellow at Aalto University, Finland, and he'll be delivering a lecture on research and standardization in IoT security. Before I call upon Mr. Mohit Sethi, I request my colleague, Professor Ranjana, to introduce today's speaker. Over to Ms. Professor Ranjana.
A very good morning, everyone. Myself, Ranjana K, working as Assistant Professor in Electronics and Telecommunication. Good morning, everyone. It's my great pleasure to introduce our today's speaker, Mr. Mohit Sethi, a man who rose up in our time of need. Mohit Sethi works as a senior researcher at Ericsson and a research fellow at Aalto University in Finland. He has received a Doctor of Science degree in Computer Science from Aalto University. He has previously completed his dual MSc degree in Security and Mobile Computing from Royal Institute of Technology, Sweden and Aalto University, Finland. He actively contributes to IoT standardization at Ietf. He also currently chairing the Lightweight Implementation Guidance, Security Dispatch, and EAP Method Update, which are working groups of Ietf. He has also received Best Paper Award at the ACM UBCOM and IEEE IoT conferences. With this introduction, I warmly welcome you, sir, for the session. Let your smile change the world, but don't let world change your smile. So with this quote, I invite, welcome everyone to the session. Thank you.
Mr. Mohit Sethi, we have made you as a presenter. It is over to you now.
Hi, did you hear me fine? I am trying to share my screen, so just give me a second and then let me know if you. So how about now? Do you see this? Do you see the slides in full screen?
Yes, sir.
Okay, I'll also share my video. I think it's a little bit better to actually see a live person on the other side, and I'd encourage all of you to also, if you feel comfortable, share your video. It's just much nicer to see a human face on the other side rather than your names. All right, sorry for being late by a couple of minutes. I was still trying to remove some of the more controversial statements I was planning to make because I was told now that this is being recorded and it would be put on YouTube. I wasn't aware of this information before, but I have to be a little bit careful with some of the statements I make, which if this was not being put on YouTube, maybe I would have been more open and frank. But in any case, don't hesitate to stop me at any point and ask questions. I'll try to be as open and frank as possible. I guess I have about an hour, so there's plenty of time. There's no need to rush through slides. It's better that we have an interactive and engaging conversation. So thank you, Professor, for the introduction. I'll be talking today about internet standardization at the IETF. So the professor already gave a slight introduction of me. I'll still go through basically what I do and where I'm based in. So I'm currently based in Finland. It's a cold country in north in Scandinavia. It's the land of Nokia, and if you have been following the media, it has now been rated 4 years in a row as the happiest country in the world. I don't necessarily think the people here are happy. I think people here are just as happy as people in any other country. So you can perhaps contact me offline if you want to ask the real meaning behind those rankings. Anyhow, I've been working at Ericsson Research for the last almost 10 years. Currently, I'm there as a senior researcher, so I work in Ericsson Research. I'm also associated with the academia, and I work at Aalto University. Since May 2017, I have, of course, been associated with Aalto University for a long time now. In the past, I've also been a visiting researcher at Carnegie Mellon. So I had gone for a short research visit to Carnegie Mellon under Professor Jason Hong, where I was also working on IoT security aspects. Of course, it's a short visit of 3 months. So the amount of work we can do together is obviously challenging in 3 months. Research generally takes more time. I have a Doctor of Science degree, so this is, I guess, equivalent to what in India we would call a Doctor of Philosophy or a PhD degree. It's just that in Scandinavia, in some of the countries, you're not a philosopher, you're a scientist, so you get a Doctor of Science degree, and the title of my dissertation was Security for Ubiquitous Internet Connected Smart Objects, which basically means IoT security. It's just a little bit more fancier words. And obviously, if you're writing your PhD dissertation, you would want to use some better words than IoT security. And as the professor had mentioned, how I ended up in these countries was basically to pursue my master's. And I was lucky enough to receive the European Union scholarship to do a joint master's in Sweden and Finland. I would encourage you to look up information about these programs online. So these, when I say, especially for bachelor students who are considering to pursue masters abroad, and even for professors, perhaps they can inform their students of this excellent opportunity where they not only like pay your tuition fee, but also pay your flights, living expenses, food, accommodation. Basically, they give you more money than you can spend. So it's when I say it's a master's which is fully funded, I really mean that it's fully funded. You won't be shelling out any money from your own pocket, and we still have this program ongoing. The name has changed, so it's no longer called Security and Mobile Computing. Now it's called SECLO, so it's Security and Cloud Computing. There is some long history on why the name had to be changed, some European Union funding regulations, but we still have association with several universities where you study 1 year in Finland and 1 year in another country, and then you get 2 master's degrees. So I would highly encourage, if there are any students in the audience, and if there is faculty, then I would encourage them to inform their students about this opportunity. So what do I do? Those were all the titles I have, but what does it mean in practice? I do applied network security research. And when I say applied, it does mean that I still write code. Of course, it's, I would say, less than what you would see in a typical software development organization. If I were working on real products, I would be spending much more time coding. But a PhD doesn't mean that I don't write code. And I think it's still quite important to keep your skills polished, and I try to do that from time to time. We also do formal modeling, and I don't know if I'll have time today to mention about what is formal modeling, but if you work in security, especially in security research, and if you come up with anything new, it's almost a requirement now also to have formal models to prove that those things are actually secure. And there are many modeling tools and techniques available. So I have been using some of them, for example, to find bugs in Bluetooth pairing, for example, or finding bugs in some of my own protocols. And that's a very important skill, which maybe is not as common or easily found anymore. So if you go around looking for people who are experts in formal modeling of protocols, there's very few people out there. And that's something to consider if you want to develop skills in that field. Uh, and one of my primary roles in Ericsson is to do security standardization. And as the professor had mentioned in my introduction, I'm currently chairing 3 working groups at the Ietf. So the third one is rather new. It happened only a couple of months ago that I started chairing the SEC dispatch working group. But it's not so hard to become a chair of a working group. So if you are going to the meetings and uh, you are a trusted contributor, I think there is plenty of opportunities to become chair for anyone. I will briefly maybe mention later on what these working groups are about. Maybe it's not so evident from their names what is EAP method update and what does security dispatch mean. Also, since I'm associated with academia and work in research, we publish papers. I think I was publishing papers much more before I had done my PhD. Now that it's done, I publish much less. But it's still something I try to do every year, is to get a couple of papers submitted and hopefully accepted. In the past, I've been lucky enough to receive Best Paper Awards at ACM, UBCOM, and IEEE IoT conferences. Finally, Ericsson also does lots of IPR. So especially if you know mobile networks, the standards development process there is heavily influenced by patents and IPR, and I am also involved in generating new ideas and filing patents on them. So I have been fortunate enough to be a co-inventor on 50 or more international patent applications. One reason this number may look a bit inflated, 50 sounds huge, is that what happens is you might come up with one idea which then gets filed in several jurisdictions. So in EU, US, China, India. So the same idea may get filed 5 times. So in the end, the number of novel ideas is maybe not 50. I would say it's probably like 20, 25, but then they get filed in different jurisdictions, and which is why I have the number here as 50. Although I would say now it's probably closer to 100 patents. Okay, so this was an introduction about me. So now I'll move to the actual content of my talk, and my talk is going to be about what is standardization and why should academia care about standardization. I guess that's a fair question to ask, is why shouldn't I just publish papers? And I think in some sense that makes sense, especially if you are on a tenure track position where your tenureship depends on how much citations and H-index you have. In that case, I would, of course, encourage you to continue focusing on publishing papers, because still some universities don't consider RFCs or standard as important as, let's say, getting a paper accepted into a top conference or journal. But in case you are already a tenured professor or a researcher like me who doesn't necessarily care so much about getting higher H index or citations, but is interested in standardization, then I guess I'll try to motivate you and encourage you to consider also working in standards area in general. Of course, I participate in IETF, so I'm a bit biased of this organization, and I would encourage all of you to participate in IETF. But there are many standards organizations out there, and you can consider others as well. So what is standardization? I guess uh, standardization is the process of coming up with standards, and then the next question is, what is a standard? So it's basically an agreement of on how things should work. Now I'm communicating with all of you in English, and you could consider the English language as a standard. There is nouns, pronouns, verbs, and there is a common understanding among all of us on how that should be interpreted, and we can communicate. And if you apply the same principles to communication over networks, we need some common standards so that we can actually interoperate and work together. And this set of rules is actually what is a standard. For example, you can have standard protocols like HTTP, TCP, IP, TLS. You can have standard data representation formats. So hopefully all of you know ASCII and UTF-8. And then there can be standard languages. So just as English language, we have programming languages like HTML5, JavaScript, and CSS. The idea being that if you write code in HTML5 and JavaScript, it will be working in any browser, and you don't have to worry about whether the user is using Safari, Firefox, so on. And the same principle is with mobile networks. So today, if you have a phone, you can be rest assured that you can travel to other countries without having to worry about whether your phone will actually be able to work. So that's all possible thanks to standardization. And sometimes we take these things for granted that, of course, things will just work together. But it's actually very hard work to agree on these common set of rules. And this is what the role of standards organizations is. So why do we need standardization? Of course, I highlighted this already, that one of the major goals is to ensure interoperability. But another goal is to ensure that your software or service is modular. So for example, if today you are making a website selling, I don't know, flowers, you don't have to start from scratch and write your own server or write your own TCP implementation, write your own HTTP implementation. You already have libraries that implement those standards. And with a few simple API calls, you can actually, start your flower selling website rather quickly. It also ensures scalability. So if you are trying to get your ideas deployed across the globe, and if your idea becomes part of a standard, there is a very likely chance that many people across the globe will be using and will be implementing and using your ideas. And this scalability and global reach is kind of interrelated bullets. There's also this more novel goal of standardization is to reduce lock-in and increase competition. It only works when standards are open. So if you think all IETF standards are open, open basically means that they are free to access. You don't have to pay any license fee to access them. Anyone can go and read how to implement TCP or UDP or HTTP and start implementing. You don't need anyone's permission to do that. And this basically increases competition. So one of the ideas of standardization is if that there is a same standard, then there will be multiple companies competing with their own implementations. There's also some aspects that maybe is not so obvious about standardization, and this is not really an IETF thing, because in IETF we don't generally do patents. But in other standards organizations, what happens is sometimes you patent your ideas and then get them into standards, and because your ideas have a patent, you will get license payments and royalties on them. So that's also financial incentives to do standardizations, although this is mostly for companies and not so much a thing for academia, because I personally think academia should not be doing patents. It should be making like research open and accessible as much as possible. Then the next question is, okay, that's all fine. There's these standards, but why should I work in standardization? Why should I leave, writing conference papers and journal papers and consider working in standards? There can be many answers. So one could be because I went to a talk from Mohit, and Mohit said that I should do standards. Or I don't know, some colleagues seem to be doing IETF or work, and maybe I should also do the same. More commonly, I have seen is that I have some funding to work in standards, so I should be doing standardization. And there's nothing wrong with this. It's perfectly fine to do standards work because there is a funded project for doing that. That can be one motivation to work in standards. Another perhaps thought is that it is more prestigious to have standards than publishing papers in conferences and journals. And some people will argue that, let's say in 2019, there were only 180 RFCs published, whereas there are like thousands and thousands of research papers published. So of course, getting a RFC is more prestigious because there's just fewer of those possible in a year. That's not true. I think it's not so clear that actually standards are more prestigious, or getting into conferences or getting your papers accepted into conferences and journals is easy. I think both are equally hard, and it depends what you are aiming for. So here I have like, I looked through this MDPI Sensors journal and how many papers they had published in 2019, and it was about 5,500 or so. But that doesn't mean that this is a bad journal. It's actually quite a highly rated journal with good impact factor and citation counts and H index and so on. So I'm just maybe the point I'm trying to stress here is that it's not the case that standards are more prestigious than conference or journal publications, and nor the other way around, that getting into like the top conferences is somehow harder than getting like your RFCs approved. Both are hard, and it's for you to decide what you want to do and when you want to do it. So if you're, of course, an early stage uh, academician who is trying to get on the tenure track or is working towards tenureship, maybe standardization is not necessary at this point. Of course, anything extra is nice, but a lot of universities care more about publications and citation counts than, let's say, having RFCs. Is there a question? I hear some noise, so should I wait or should I continue? Okay, I'll continue. I don't hear any questions. So yeah, this was just kind of emphasizing that more doesn't necessarily mean bad quality, and less does not necessarily mean that it's more it's prestigious. Things are always things are never black and white, and they're always gray. So it's for you to decide whether you want to do that or not. Another thing that perhaps students might consider is that maybe getting working in standards is good for my career. And I think for some students, indeed, it's true. There is like I can say for companies like Ericsson, Nokia, and others, they are looking for experts in different standards, whether it's IETF or 3GPP or Wi-Fi or IEEE. So if you have like some experience and you can already show that you have some standards experience, then perhaps getting a job for you in the industry will be easier, at least in some cases, not always. If you're going for software development, maybe standards work is not as valuable, but certainly if you're going into uh, uh, companies like Ericsson and Nokia, standardization is very valuable to have as a skill on your CV. Whether this is doing standards work is good for a career as a professor is again for you to decide. I think I'm way too junior and young to make any comments on that. At least I have seen that once people have permanent tenured positions, they have more flexibility and try to work in standards as well. But early on in their career, perhaps there's more focus on publishing. So really now the final answer, why should I work in standards? Well, one I already highlighted on the previous slide is that there are companies who are looking for standards experts, and working with standards is an excellent way to do some capacity building. So like if you think of any big company and that goes to a campus to recruit students, they will almost certainly not find any students who have worked with standards or even heard about standards. But if there are some students who have that experience, that would definitely be an edge. So that's something to consider, that industry needs these people, and perhaps we should train students to be aware of them, if not actively participate in standards work. Another motivation, which I think is important for me personally, and hopefully for some of you, is also that writing papers and getting them accepted into conferences is all nice, but how do you actually make impact? And with impact, generally, I guess would be, how do I see my research getting deployed in people's hands? And some of my colleagues work in mobile network standardization, and they can proudly say that this phone you are holding in your hand has actually things that I have worked on, and there is obviously a different ring to it. So that's one very strong motivation to consider work is in working in standards, is to get to actually see your research getting deployed and used by users. But this does not mean that writing a RFC or working in IETF will necessarily mean global deployment. So just because I have a standard, everyone will start using it is not necessarily true. There are many different factors that play into whether your standard will actually get deployed or not. I guess the final thing I want to say in this series of slides is, if you really want to see your research in real products, perhaps the most important thing is to have running code. And whether you do standards or you publish papers is good. It's nice for other people to know about it. But if there is no implementation, it almost no one else is going to write that implementation. People just don't have the time. So if you write a standard or a paper and expect someone else to do the implementation, it's almost unlikely that it will ever happen. So it's almost a given that we need to do the implementation. And from my own experience, I have done lots of prototype implementations, to get some measurements, make some graphs, and write papers. But there's a big difference between prototype implementations and implementations that actually others can use. What is another common trend is that, oh yes, I have an implementation and it's on GitHub. But if I start, trying to use your code, it doesn't compile on my platform. And of course, it worked in the lab when the prototype was being made, but it does not work anywhere else, and people are having a hard time to actually try to run your prototype implementation. So in that case, hoping that your research will actually get deployed is maybe wishful thinking. So maybe the takeaway from this slide is that if you want your research to actually end up in real products and services, it's very important to have high quality implementation. Only prototypes are not enough. Only putting things on GitHub is not enough. And of course, it's a lot of work, and maybe this is also like a hint to the university leadership that these performance metrics of ETH index and citation count is good, but there are also other important things. And if you really care about getting research deployed, writing software, high quality software is as important as writing high quality academic papers. So what are standards then good for if running code is the most important thing? Standards are good for getting technical feedback. So especially in standards organizations like Ietf, you can write your initial ideas and present them, and you will get very critical feedback most of the times, which is of course painful because it's your idea and you are so passionate about it, and then you go and present it to people, and there will be people saying,
objective function called as
sorry, there's some background noise. Anyhow, I'll continue. So yeah, there's like lots of technical feedback that you receive if you take your work to a standards organization. Also, building on existing standard increases your chances of deployment. So if today you build something from scratch, getting it deployed is probably going to be a challenge. Instead, if you use existing standard and build things on top of that, perhaps the chances of your research getting deployed is higher. Another good thing about participating in standards is you can gauge interest from industry, and it does happen a lot of the times that folks from the academia present some new ideas, and then the companies participating in standards, you name it, Cisco, Google, Apple, some of them might be interested or might be encountering the same problems in real networks, and you will be able to get some nice collaborations with them. And you'll also learn about real problems that they encounter in networks. So let's like one good example of this is like how I feel about the research in cloud computing. There's lots of us who do research in cloud computing, and sometimes I know some of my colleagues who have been very active in cloud computing research. But if you go and look at their lab, the lab is basically one big box, which is like has lots of CPU, RAM, and you can run all sorts of Kubernetes and Docker containers, but it's still a box that is under the table, and that is not a real cloud environment. So if you don't have access to actual server farm, with racks, doing research is going to be a little bit of a challenge. And this is where participating in standards can help, is because you can actually meet people from the industry who have access to these big server rooms and can tell you about real problems they encounter. Another good skill about standards is to learn to write more precisely. And this is something I also learned the hard way after participating in IETF over several years. And I think there's like still lots to be improved, both in myself and in others. So in a research paper, let's say if I write that we take hash of a string, most of the time reviewers will be happy and will not ask more questions. But if you're writing the same thing in a standards specification, you would need to be very precise. So you would need to be which hash function you use. Let's say use you now agree to SHA-256, then it would be which byte order you use. Is it network byte order or host byte order, and which bits are used, MSB or LSB. So you need to be very precise to the level of bit and byte when you're writing standards. Otherwise, things will not interoperate. And finally, standards are good for reaching a global audience. So that's another reason to consider pursuing some of your research, at least as standards work. So I'll take pause here and see if there are any questions on like why standardization is useful even in academia. If there are any questions, I could take them now or then continue.
Sir, how can we get involved in the standardization?
Yeah, that's a very good question. So maybe I'll answer this on the following slides, and this is a good way to lead into my next slides. So there are many standards organizations and consortia. So I'll be mostly focusing on IETF, where I participate, but there's Wi-Fi Alliance, 3GPP, ETSI, IPSO, OMA, IEEE. And as academia, I would say the easiest organization to participate in standards development is the IETF, because it's open to everyone. You don't actually need to have like a company affiliation. So you don't need to work for a company to join, let's say, the IETF. You can subscribe to mailing lists and participate. And I'll tell a little bit more about how the IETF works in the following slides. But let's say to participate in IEEE or Wi-Fi Alliance from a university is much harder. You actually need to belong to a company to do that. So it's not always easy to participate in all standards organization, but some of them definitely it's very easy and actually encouraged. So IETF, for example, I know has lots of people from universities who come and participate in standards development. So they might write a paper about it, but then also write IETF RFCs about some of the research. So generally, how one way of doing things is to write a research paper and get it accepted into a good conference or journal, and then kind of bring same work into the IETF as a standard, and if there is interest, then it will eventually become an internet standard. So it's not mutually exclusive. You can do both. Obviously, IETF takes much longer time. So from my own experience, I can say like getting a RFC will take you at least three years, whereas getting into a conference or a journal is hopefully 6 months or maybe a bit more or a bit less. So timelines are a little bit longer in standards because you need to agree with so many companies. So yeah, I'll now the second half of my talk basically tell about what the IETF is and what does it do. So it's a core internet standards organization. It develops and maintains standards for technologies used to provide internet service. So basically, if you are an internet service provider or ISP, you would be probably working with a lot of IETF standards. And at the same time, if you are a company like Apple or Google, where you provide web services, you will still be working with a lot of IETF standards. Standards are published as RFCs. So I had been referring to RFCs in my previous slides. I should have stated it earlier that RFCs are standards, are internet standards that are published by IETF. And as I had stated earlier, they are open and free, so anyone can go and read them and start implementing them. They don't need any permission or license to do that. And the same is with the rest of the participation. So you can actually participate in IETF standards development without having like a company affiliation. You can subscribe to mailing lists, comment, ask questions, and so on. So it is in that sense a very welcoming and open organization. Some important standards that IETF has done in the last couple of decades is IPv4, IPv6, TCP, UDP, TLS, DTLS, and HTTP. I'm sure all of you are familiar with these protocols. It's just that when at least I studied them at university, I wasn't aware that these are actual standards that are written by an organization. So there is people who actually write how every bit and byte and flag should be interpreted. And this is obviously important work. And these are some of the most important standards. That doesn't mean all IETF standards are equally important. Some of them never get deployed, and some like here, like IPv4, IPv6, are deployed almost universally. So I think there's pretty much everyone in the audience today is using some of these IETF standards even to participate in this meeting. So how is the IETF organized? There is a chair, and then there are area directors. And IETF is divided into areas. So this is basically to modularize the work and manage. So we have general area, we have applications and real-time area, transport area. So this is where you will be doing a lot of work on congestion control and things like QUIC and TCP, UDP. Then we have routing area where you will be working, if you have some new ideas on BGP, MPLS, and so on, will be in that area. Then we have internet area where there's more work on IPv4, IPv6, neighbor discovery, things like that. We have operations and management and security, and these are sort of cross-cutting areas. So for example, operations and management would be like YANG modules, SNMP, and security is then across areas. So you can have securities working on different layers from routing to all the way to applications area. And things like TLS, which is almost now widely used, very widely used protocol, is developed then in this security area. So we have these areas that you saw on this slide, and then we have working groups. So there's smaller working groups, about 130 working groups right now, and these can then work on like more specific topics like HTTP BIS will work on anything that is related to the HTTP protocol. TLS will work with anything to do with TLS and DTLS protocols. Then we have the core working group, which is working on protocols like CoAP. Another important thing about IETF is that most of the work happens on mailing lists. So you don't actually have to go to the meetings or even join the video conferences. Like all agreements are happening on public mailing lists, and anyone can join. So you can even join with your Gmail account. You don't need any university email address and so on. So in that sense, it's very open. And once you subscribe to the mailing list, you can provide comments, or you can say that, hey, I have this new idea. Is there someone else interested? And so on. We do have IETF meetings that are held 3 times a year, or used to be held 3 times a year when we were still meeting physically on 3 different continents. Now they happen virtually. So far, we have had the, I think, 4 meetings virtually since COVID, and let's see when we will get back to physical meetings. But the important thing is that even when there are physical meetings, you can participate remotely. You don't have to actually travel to those far-flung, locations necessarily just to present 3 slides or 5 slides, you can also present them remotely. Of course, it's a little bit easier to progress your work if you actually travel to the meeting and you get to meet the people physically and discuss your ideas and bounce around ideas with them, because most of the times when you first time present your idea, maybe people will not understand, or maybe people will think that this is already done, and it's uh, important to have like corridor discussions and discussions over coffee to actually progress some of your ideas in standards. There's about 1,000 or 1,200 people in every meeting, and most of the works is done by working groups. So you can join any working group. There is no limitation on which working group you can join. So I'm sure if there is any topic you are currently working on, there is probably a Ietf working group which is working on similar topics. So you can perhaps participate there. And it's a voluntary standards development organization. So what I mean by this is that nobody gets paid to do this work. So if I'm chairing 3 working groups, I'm not getting extra salary. I get my usual salary from Ericsson where I'm employed, and this chair is then, let's say, voluntary work, or writing RFCs is voluntary work. And this is how it remains an open organization where everyone can participate, and academia is especially welcome. Then some more information about IETF. Perhaps this is the most important sentence that they say. So we reject kings, presidents, and voting. We believe in running code and rough consensus. And what this basically means is that in IETF, they don't have voting on any ideas or proposals. So it won't be that you go to a room and they will ask you to raise hands and say 10 people are supporting and 5 people are opposing. So we will accept this idea because there is a larger number of people who are voting in favor of this idea, because it won't be fair for smaller companies and people who participate from university if it were simple voting. So what basically IETF considers important is that you need to have, for any idea you present, you need to have like implementation and running code, and that is very valuable. So if you present an idea which is not yet implemented, people will be a little bit more skeptical. But if you present some new idea and say that I have one implementation, or preferably with 2 or 3 implementations that interoperate, people will consider that idea more carefully. And rough consensus is again basically that there is no voting, that 10 are in favor and 9 are against. So the larger number wins. It's more that people try to come to some kind of rough consensus, and this is where it takes a lot of time. So when I said that getting your idea published as an internet standard will easily take you 2 to 3 years, it's because you need to get others to agree to things, and that generally takes a lot of time. So consensus building is a lot about time and negotiations. Finally, you are identified as an individual and not as your organizational affiliation. So when you go to the meetings, it's perfectly fine to introduce yourself as Mohit. You don't have to say, hey, I'm Mohit, I come from this company, or I come from this university. This is again like more egalitarian ideas, that everyone is equal and is treated as individual. And it doesn't matter whether you come from a startup or a big company or then a university. There's a couple of bullets on how the leadership gets elected. This is again very democratic in some sense, that there are volunteers who vote on the IETF leadership. So the 1,000 or 1,200 people who participate in the meetings, some of them are randomly chosen, and then they vote on who becomes the chair and area directors. This is not so perhaps important information for this talk. Okay, so I spoke a lot about IETF, but there is many associated organizations, some of which you may have heard about and some not. So there's the Internet Society. Then there is also, now I realize that I have gone through so many slides and never even mentioned what is the full form of IETF. So IETF stands for Internet Engineering Task Force, and there is a sister organization called Internet Research Task Force. And this is where more research ideas come and are presented. So just as IETF has working groups, the Internet Research Task Force has research groups which are more open, uh, even more open than the IETF, where you can present very initial ideas, you can write survey documents. So for example, I was co-author of RFC 8576, which is basically providing an overview of IoT security and what kind of attacks there are, what kind of countermeasures exist. So IRTF is another place to another venue you can consider to participate in. So we have several research groups, including things like quantum internet. Then we have CoinRG, which is mobile edge computing and things like that, and also T2TRG, which is thing to thing research group, which mostly works on IoT ideas. And the role of this IRTF, or the Internet Research Task Force, is that maybe some of the more preliminary ideas go there and get published as RFCs, and once there is enough experience, they can also be published as internet standards via the IETF later on. There are many other these internet organizations. So there's the Internet Architecture Board, then there's the IANA, Internet Assigned Numbers Authority. So maybe I can say a couple of sentences about IANA. So IANA is a authority that just registers numbers, and you can think of all sorts of numbers. The best example is port numbers. So, TLS, or for example, uses port number 443, or HTTP uses port number 80. But who agrees to this or who registers this, that is what IANA is responsible for. So you can go there and say that I want to register this port number for this protocol, and then IANA can either assign it or reject it. But this is where all the registrations happen. Then there is the steering groups. For the IETF, there is the Internet Engineering Steering Group, and for the IRTF, there is the Internet Research Steering Group. So this is basically the leadership team which kind of reviews all contributions and decides whether they should be published as RFCs or not. But it's not like some opaque body where you don't know why they are making some decisions. It's again very open. They will communicate with authors on what issues exist and what needs to be resolved, and so on and so on. And then we also have ICANN, which is this Internet Corporation for Assigned Names and Numbers. And this is then the organization that is responsible for domain name registrations like .org, .com, and registering all the top level domain names like .com and so on. How are these organizations in hierarchy? Something like this, but I don't think it's relevant for you. I don't think you should care in what order these organizations are. It's just to let you know that if you participate in some of these meetings, there will be lots of these high regulated organizations. Is there a question? No? Okay, so I'll continue. So what is an RFC? Well, it's basically a published standard. I should have updated this. The RFC number is now current RFC number is way past 8,026. I guess it's already at 9,000 something. So since the last time, it has already been 1,000 more RFCs published. Another important thing is RFCs are never changed. So once they are published, they remain online forever. So that's another reason to consider doing standards work, is that once you get a standard, it remains online always. So even the original RFCs that were published in 1969 are still available online. They never disappear. So this was maybe to answer the question of Professor Rajeshwari on how you can publish a RFC. So generally, you start by writing some ideas in an individual draft, and you can submit this. You don't need any permission. You basically write in a text file, uh, and there is a template of how to write this, but you can look at some existing RFCs and then try to write your own draft. And basically, you can submit this individual draft online. You don't need any permission to submit this, and it will be published. Then you will probably participate in some working group meeting, and you will present your idea with slides, and you will get feedback that this makes sense, or this doesn't make sense, or this should be improved, so on. And this cycle can be several months. So it's not like you present some idea and it just gets most likely there will be several rounds of feedback and improving the document before there is a formal call for working group adoption. And basically this means that the working group thinks that this is something the entire working group should work on, and it seems an important topic that all the working group should work on, and then they formally adopt it. And then again, it would go through several cycles of feedback and improvement, where people will try to come to some sort of consensus on what the RFC should look like. And once that is done, then you have the working group last call, and it's sent to the IETF leadership, which is called the IESG, and they review the document. And if they think that this document is okay and all concerns have been addressed, there is implementations of the idea, then it will be published as an RFC. So this is one way of getting involved. Of course, there can be other ways. You could join as a co-author on some existing drafts. Perhaps the best, in my view, best way to start participating in IETF is not by writing your own drafts. It's by actually reading other people's drafts and commenting on them. And most often people are very happy if you read their work and can provide comments. Even if you find some small spelling mistakes and send that to the mailing list, that sending a simple email saying, I read the draft, I found it interesting, here is a couple of spelling mistakes, and here is a couple of things that I think could be explained better, will already reflect very positively. Of course, you can also bring your own drafts, but if you're new, it's maybe a little bit easier to start by commenting on other people's work than by presenting your own idea. And another reason I say this is sometimes people in standards can be very critical, so don't be afraid. I think I also learned it that when I went to, let's say, this was some time ago when we were still going to conferences and presented a research paper, at the end of the 20-minute talk, maybe there will be two people who will come to the mic and ask you a question, while maybe others were checking their emails and or were just sleeping in the last row or something. Whereas in the IETF, many times you would start presenting and people will already be asking you questions. They will not wait for you to go to your last slide. It has happened to me that I have been on my title slide and I have been stopped to ask questions, which is perfectly fine. I think it's very refreshing that people are actually actively listening and reading and commenting on things, even if they can be sometimes critical. I think over time you learn to accept that initially some people might be critical. You just have to explain your ideas and get them around to understand your points of view as well. So now I think I've already spoken for almost an hour. I'll try to kind of conclude. So in the last few slides, I'll basically tell what kind of working groups there are, and hopefully you'll get some ideas in which working groups you can you would be interested to participate in. So here is a list of some of the IoT working groups. So I am currently co-chairing this lightweight implementation guidance, or LWIG working group, and basically this working group is about writing about your implementation experiences. So for example, one of the RFCs that this working group published basically shows that you can do efficient elliptic curve cryptography even on small devices. So that's RFC number 8983. And so there was nothing new. It was just showing that even small IoT devices can do elliptic curve cryptography, and that was then published as an informational standard. We also have Lake, which is lightweight authenticated key agreement. So this is working on a new key agreement protocol for IoT devices. The proposed protocol is called ad hoc, which is this ephemeral elliptic curve Diffie-Hellman. Then we have things like Suit, which is software update for Internet of Things devices. So this is working on, manifest file formats and tools and techniques for doing secure software updates on IoT devices. Then we have this ASDF, which is doing more of semantic definition and semantic interoperability in IoT devices. So how can IoT devices understand each other? In what language they should communicate? How does an IoT light bulb from one manufacturer talk to a IoT light switch from another manufacturer? So that kind of work happens in this working group. We have also like Role working group, which has published many RFCs on routing in IoT networks. So they have a routing protocol called Role. We also have 6TISH, which defines how to do IPv6 in TSCH networks. And then we have 6LoW, which defines how to do IPv6 on all other link layers. So for example, how to do IPv6 over Bluetooth, how to do IPv6 over 802.15.4. There's even specifications on how to do IPv6 over NFC. We also have LPWAN working group, which is working in areas like LoRaWAN and Sigfox and things like that. How to do header compression and so on, so that the packets are really small and can fit into LoRaWAN packet limits. Then we have CBOR. This is a data representation format. So if you are familiar with JSON, which is this JavaScript object notation, then we have an equivalent, which is called concise binary object representation, or CBOR. And this is now being very widely used in almost all new IoT protocols. So I think it's important perhaps to learn about CBOR if you're going to work in IoT in the future. I see more and more standards bodies and protocols using CBOR. Then we have some secondary working groups. We have, as I had mentioned, we have T2TRG, which is a research group, thing-to-thing research group, where you can also, bring some new ideas about IoT. So you can submit a draft and then ask for time to present, and generally the chairs will happily allocate you time to present your new work. We have CFRG, which is the Crypto Forum Research Group, where basically all new crypto algorithms are standardized. So if you are a mathematician or have math background, perhaps this is the right research group for you. And almost all new security algorithms are first vetted by this research group. So, if there is some new mode of AES or whether SHA-256 should be now abandoned and should we all move to SHA-512, those decisions are made by this research group. And once this research group issues a recommendation, then the rest of the IETF kind of follows that. There is also TLS working group. TLS, I'm sure you're familiar with. DTN is then again something you're familiar with. DRIP is something relatively new in the IETF, and this is working on protocols for drone identification. So if you have drones in the neighborhood, I guess a lot of governments now want some ways of identifying who the drone owner is and should this drone be shot down or not. And this working group is working on protocols for drone identification. We have HomeNet, which is doing home networking, how to do automated, prefix assignment and things like that in home networks. Then we have OAuth working group. OAuth is used for authorization on the web, and there's also work on how to do OAuth in IoT devices. And then we have RATS working group, which is basically doing this. If you're familiar with TPMs and TEEs, these trusted platform modules and trusted execution environment, what kind of protocols are needed for telling the state of IoT device, whether it's still functional and authentic and so on. So I think I will stop here. I have some more slides on what these working groups have been doing. So for example, there's more information on CBOR, ACE role, but I think these are too text heavy. So it's probably just nicer to look at these bubbles and get an idea of what kind of things the IETF is currently working on. So, okay, I'm done. I think I'm open for questions.
The session is open for questions. Participants can unmute themselves and pose the question to the speaker. Fine. That was Mr. Mohit Sethi on research and standardization in IoT security. We would appreciate the time and effort taken by Mr. Mohit Sethi in presenting a topic which is very relevant to the researchers, especially in the field of IoT security. From the Department of Electronics and Telecommunication Engineering, I would like to extend our warmest thanks to Mr. Mohit Sethi for taking part in this program. Thank you very much, sir. I do remember at the beginning of the session, sir, you said you're going to tell us why Finland has been listed as most happiest country for the 4th successive year. Can you share some of the things on it?
Sure. So I think when these, this is my interpretation of these rankings. Obviously, this is not scientific explanation of why I think it has been ranked number 1 4 years in a row. It's not because they come and ask people, are you happy? I don't think the surveys are conducted in such a way where they actually go and ask people, because I think people are the same. They like to complain everywhere. So if you randomly go on the street, I'm sure everyone would have some problems and complaints. What these surveys are basically measuring is Things like healthcare. Does everyone have access to healthcare? Is there social security? Is there good public transportation? Is there corruption and things like that? And so basically, these rankings are saying that you have every reason to be happy, that like you have good healthcare and less corruption and so on, but that doesn't necessarily mean that people are happier. So yeah, I guess that is my interpretation, that in general it's a functional socialist society where everyone is taken care of and you don't have to worry about most things. There's like not so many big traffic jams, and there's low crime and so on. So you have every reason to be happy about your life. But I don't think people are necessarily super happy. They still like to complain.
Well, the list of the most happiest country includes top 4 being European countries. From my end, I just take it as, is it the population that is contributing towards more of the happiness? You have a lesser of population in those countries as compared to, say, India or Asian countries.
It looks that it is more with reference to what we say, that our content level and our satisfaction, that we don't, and even the problems, we are up to these situations. Maybe that's one of the great criteria. Somebody said that you are ranked as a happy person.
Okay. So it seems there is a more of a debate on happiness than on IoT security. Okay, sir. Anyway, thank you. Thank you for your active participation. We look forward to have more of your interaction with you in the days to come. Thank you very much, sir. And for the participants, this session in the afternoon begins at 2 o'clock. And it happens to be the concluding session also. We would request all of you to take part in it. And if you have any queries, you can put it in the chat box or you can communicate with us through mail. And hopefully, you are all giving us the feedback. The links are shared. And for today's session, we are going to share the link now. Please take time to give us the feedback. Please wait. The link will be shared now for the feedback.